Hello.
Good afternoon, doctor.
Good afternoon, Dr. Francis.
Yeah, good afternoon. How are you?
Very well, sir. And you too.
Okay.
Good afternoon, Doc.
Yeah, good afternoon. All right. Are we starting now, or is it we are waiting for?
I think we can start now, sir. We are about 6 currently, thereabouts. We are about 7 now, so I think we can start. I don't know what IJ thinks. Hello, IJ. Okay, I think we can start. We can start, sir. IJ has responded in the chat.
All right, that's fine. Where did we stop last? Where did we stop in our last session?
I think we discussed. I think we stopped at data filter, table slicing, and data filter. I don't know if someone want to confirm that or. I know we did data slicing and data filter, but I don't know whether that's the last topic that we did.
Data filter. Have we done the t-test, ANOVA? Do we do all those tests?
Yes, sir.
Yes, we did.
Oh, we have. Okay. So which was the last test that we now ran? Somebody should confirm what was the last test we ran, so I know where we continue from. Yes, confirm which test did we run last?
It was just that and over.
Did we do t-test?
No.
Yes, we did the test.
Or we did
I think, yeah, t-test, you mentioned t-test for small size,
okay.
and large size, z-test.
Okay, that's fine. Okay. So you see, when you want to analyze most data, isn't it? You have certain objectives you want to achieve, right? That's the essence of carrying out the analysis, because there's a business problem, right? And that problem is what you put in form of what? Questions. Okay. Now, the one you have been doing in Excel is mostly you are just trying to describe, because remember in analytics, we have what they call descriptive analytics, isn't it? We have diagnostic analytics, predictive analytics, and we have what they call prescriptive analytics. Okay. So what we have been doing before, we just summarize the data and visualize it. Okay. Now, what we have been doing so far is that when we want to take decisions, because when you are trying to analyze using statistics, it's either you want to what, compare, Is it not, you want to find relationships, or you want to what, make what, predictions? Okay. So what we have been doing is that we want to what, compare between two or between three or more. Okay. So if I'm just comparing between, so I either use t-tests, right, or I'm using what, ANOVA. But you can also use chi-square, but chi-square is test for proportion. You can use chi-square too. Okay, these are different tests. If I'm looking for relationship, then I can talk about what, correlation. Okay. Then if I want to do prediction, then I'll look at what, regression. So that's why once you have the questions, you have to identify the variables. Okay. So the kind of variable you have will now determine the kind of analysis you are going to do. Because generally, when you have your data sets, right, at the end of the day, what you are trying to do is that when I have the data, I'll first of all need to what, import that data. Okay. We'll first of all import the data. I'm sure by now we all know how to import data, right? We'll what? Import the data. So either the data is a CSV file or an Excel file, isn't it? Much later, maybe we'll look at how to connect with SQL and maybe web. So you can get data also from a database from the web, okay? But most time, this is what we do. We get it from a CSV file or an Excel file. Then once you get the data, the next thing you need to do is to what? Clean the data, isn't it? Clean and transform the data, okay? Now, after that, what you can also do, you can also manipulate, right? Just check, group the data. So all those ones, they're called manipulation, just to check what the data looks like, okay? Sometimes they will call it EDA. What does EDA stand for? What does EDA stand for? When you hear EDA,
Exploratory data analysis.
exploratory data analysis. Also, you can also summarize. Sorry, please, can we meet your mic, please?
Today. Saturday.
Victor, please, can you mute your mic, please? Oh, thank you. So you can also summarize the data. You know, your descriptive statistics, where you have your minimum, maximum, mean, average, median, all those are summary statistics or descriptive statistics. Okay. All those are part of your EDA. You're trying to what? Explore the data. Okay. Then you can also visualize the data to just see what it looks like, isn't it? So you can do your box plots, you can do your histogram, you can do your bar chart. So all that just to explore what the data will look like. Then we can now do some tests. Those are now the analysis. You can now analyze it. So those are the tests we'll now perform, okay? Then before you now interpret and make what conclusion. So all these are the things we'll normally do, irrespective of the tool that you are working with, whether it is Excel, whether it is R, whether it's Python, okay? These are basic things that we are trying to work through, okay? So we have looked at the data and we have seen that most times when we get this data, we need to understand the kind of analysis we want to carry out, okay? Because it's the questions that you have that will determine your objective of your analysis, okay? It's the question that you have that will determine the objective of your what? Analysis. So we are saying, for example, if you have to compare, we want to what? Compare between two groups. Okay, I want to compare between what? Two groups. If we want to compare between two groups, right? What kind of test are we going to use when we're trying to compare between two groups?
T-test.
Yes, you can use your word t-test. So normally, in theory, when your sample size is small, normally they tell you to use word t-test. Then when your sample size is large, they'll tell you to use word z-test. That's in theory. However, in practice, what you will notice is that as the sample size gets larger and larger, your t-test and z-test, you arrive at the same conclusion. We are not saying you get the same value, but you arrive at the same conclusion. If it's reject, both will say reject. If it's accept, both will say what accept. So that's why you see that most softwares always will use what the t-test. Okay, that's why you see most softwares they use t-test. It is only very few softwares that have z-tests, and one of the few softwares is Excel. You know your data analytics 2-pack in Excel. So Excel has z-test, one of the few softwares that have. Stata also has it, okay? But for R in itself does not really have that z-test like that. But the good thing about R is that you can customize your own if you absolutely have to use it, okay? But however, the t-test will help you what? Arrive at the same conclusion. Okay, you arrive at the same conclusion. Okay, so when you are trying to compare between two groups, so you can do before and after. So it all depends on how you now classify your data, which is group 1, group 2. Okay, but when it now comes to 3 groups and above, then we now use what? ANOVA, analysis of what? Variance. So which data set do we use that day? Was it hypothesis? I think it was hypothesis. Let me see where I have my R. Hypothesis. Let me copy the part. Yes, let me copy the part. So first of all, it's an Excel file, right? So I have to bring in the library. What's the name of the library? What's the name of the library? Read what? Excel, isn't it? So I can call, yeah, so then I call it in the variable. What should I call it now? Should I call it, let me call it T, right? So what do I call now? How do I call it now? How do I call it? Yes, how do I call it now? So how do I import the file? How do I import the file?
Read underscore Excel, is it?
Read what?
Read underscore Excel. Department.
Read underscore Excel, isn't it? Open brackets. I'll paste it, isn't it? And I'll change my most time you see this one we are doing, we can also create a directory, a working directory, right? Where you can put all the files. Then in that case, I don't have to now call up this location. But most times, if you are not working with a particular folder, then you have to go to the location where the data is. All right, so we have several sheets, so we have to call the sheet name, isn't it? So what's the sheet name? What's the sheet name? What's the sheet name? Is it t-test or whichever? All right, so let's say view T. All right, so that's the before and after, isn't it? Before and after. The one of ANOVA, let's call ANOVA. Okay, ANOVA. So the same thing, I will call it up. I will call it up. But in this case, the name will be what? ANOVA, right? ANOVA. Okay, good. So if I want to view the data, I can just call it what? ANOVA. So that's data, isn't it? Good. So we know how to import data, right? We know how to import data in R, isn't it? Whether it's an Excel file or a CSV file.
Yes, sir.
Yeah?
Yes, sir.
All right, good.
But
So,
Dr. Is there a way
yes.
to import? Is there a way to import all the sheets at once?
To import all the sheets at once.
Yes. Is it feasible?
Yes, it's possible. But remember, it's possible now. But remember again, it now depends because they are not in the same structure, right? They are not all in the same structure. So what you would have done is that you can call all of them like this, isn't it? Call all of them like this. The only thing you will call it just be changing their sheet name, and you can import them at once.
Okay.
You understand?
Yeah.
But if they were in the same structure, I think we showed it. I think either the first class or second class. Now we showed how to import and merge and append all of them together in one sheet. Especially when they have the same structure. Yes, we can bring them. Yeah, we can bring them together. But since this one have this French structure, what you can do once I copy one out, the only thing I'll just to be changing the sheet names, and I run it at once, and you bring all the data for me.
All right. Okay.
Yes.
Okay.
All right, that's fine. Okay, good. So if I run C now, so look at this. So for example, now so in this case, I'm looking at group. Can you see that before, after? Now, assuming I wanted gender, male, female, that means in that case now, the kind of analysis I would have done, is there a difference between male and female performance? Can you see that? So it means my variable here will now be performance, isn't it? You can have here performance, right? You can have the gender, you can have the scores, male, female, male, female. Maybe it was taken over a period of time or at a point or whatever. Okay, so you can write all the either the names or whatever. You can have the gender here, male, female. Then this will not be the scores. Okay, so you can have different kind of. So it depends on how it's as long as it's just two you are looking for, isn't it? It can be maybe you are looking for the sales between two regions or two states or two countries. So I can have the country one, country two, and I have the sales here. So it is this one that is more important. Can you see that? All this one just to guide you what you are trying to analyze. Okay, what you are trying to analyze. So you can have before, you can have after, you can have gender, male, you can have female. So all depends on how you want to structure it. But whatever you want to find difference, this is what will be here. Okay, before and after, before and after. And remember, it is not marking them one for one. It is looking at what on average. Can you see that? On average. Because if we look at it from here, we say, there's a difference, isn't it? But what we are checking is the difference significant. So we are checking that what on average. And if you remember the formula for your t-test, it is the mean 1 minus what? Mean 2, isn't it? All over what? Is it 1 all over n1 plus 1 all over n2? You find the square root times what? n1 minus 1 plus n2 minus 1 all square. So something like this. So this is your pair t-test. But we are not bothered about the formula now because you see what we are trying to do is to compare what the average. Can you see that the average? And this is like the standard deviation. This is like the standard deviation. Okay. So you are comparing the average. So they have already built the formula for you already. So you don't really have to bother yourself. The only thing that you just need to understand about this is how to interpret. Is it not? And how do we interpret? We are going to use what? The P value, isn't it? And what's the rule? What's our rule? What is the rule? Yes, what is the rule?
The rule is that the level of significance should be 5%.
Yes. So if our alpha by default is 5%, so how do we know when to accept or when to reject HO? Yes. How do we know when to accept or when to reject HO? Based on the rule. Yes, if p-value, if that p-value is less than 0.05, isn't it? If we check that p-value and that p-value is less than 0.05, what do? We reject HO. But if that p-value is greater than or equals to, is greater than 0.05, then we what? Accept HO. Technically, they will tell you do not reject HO. Okay. So remember, at the end of the day, we are checking whether it was significant. Okay. So either we are looking for what? Two things. Either it's a significant difference or a significant what? Relationship. Those are the basic things that we do with statistics, okay? Because remember, we are trying to compare. We are trying to find relationships. So that comparison is different. So is there a significant or difference? If it's one population, we use t-test. If it's two or more population, we use ANOVA. Okay, so basically that's what we do. Okay. Then if it's relationship, we are talking about correlation and regression. Okay, but we are checking if it's significant. Because remember, in correlation, what we are looking for is what? The direction of relationship, whether it's positive or what? Negative. Then if we check the p-value, whether it's significant or not, then we can say whether it's a significant relationship or not. All right, good. So once we have imported the data now, so we looked at the t-value, isn't it? So if we want to summarize this now, how do we summarize it? Just a summary, isn't it? Summarize t, yes. So to summarize, it's like your, what they call it now? Your descriptive statistics, isn't it? It will tell you the minimum, tell you the maximum, tell you the median, tell you the average, right? Then again, if you want to plot your box plot, so your box plot is just like the visual representation of your summary. And again, remember, most times you have a lot of libraries by default, isn't it? But sometimes you also need to call the libraries, especially when you manipulate your data, okay? Especially which are the two major libraries in R for data analysis? You know, like in Python, now we have pandas and NumPy, isn't it? Pandas and NumPy. In R, which one is the major ones?
Deep layer.
Read R.
Yes, deep layer.
Read X. Okay.
And what? Which one is the second one?
Tidyverse.
Tidyverse.
Yes, exactly. Tidyverse. Those are the two major libraries, isn't it? So most times just bring them first so that just in case you won't forget. Okay, good. So if I was to plot the box plots, what was the name of the data? T. You know what this $sign is it not? So that $sign is now to access the listing there, the column. Okay, so T before, T after, isn't it? So if I do a box plot, can you see that now? So this is one is before, two is what? After. So virtually, is there a difference? Is there a significant difference?
Yes.
There is a significant difference, isn't it?
Yes, there is.
That means that if I was to do the tests now, if I call the t-test, now you see the X now is my data, t-test before and after. So let's say t before, comma, t after. Now, what kind of test are we doing? Is it paired, right? Paired t-test. By default, I think by default it is usually true. By default, it is what? True. Okay. So when you say pair, that means they are exactly the same size, right? If they are equal, then you say true or false. So it all depends. But in this case now, they are exactly the same size, isn't it? So what do we now do? We just check. You check the p-value, isn't it? The p-value. So what's our decision? What's our decision? What's our decision?
Accept.
I say, what's our decision based on this? There's a difference. Okay, reject. Good. So what are you looking out for here in this place? What are you looking out for? In all these results you are seeing here, which value are you looking out for now?
P value.
The p-value, isn't it? And can you see how they stated the hypothesis? Alternative, the true difference in the mean is not equal to 0. That means HO is that the true difference in the means is equal to 0. Equal to 0 means what? No significant difference, is it not? Not equal to 0 means what? There's a difference. So that's what it just simply means. So when we look at this p-value, does it mean 1.929? This p-value, does it mean 1.929?
No,
It is what?
an exponent.
0.00000.
Is it not?
Yes.
Exactly, 129. So you can summarize this one as what? 0.00, is it not? So this is the p-value. Is the p-value greater than or less than 5%? Is it less than or greater than 5%? This p-value?
Less than 5.
Less than.
Less than 5%. So therefore, what do we do? Conclusion?
Reject.
We reject what?
Null hypothesis.
No hypothesis.
All hypothesis.
Clear? Is that clear? So that's why that p-value, irrespective of the analysis we are doing in statistics, this is what you are going to always be using. I hope this is okay now. Are we okay with T now?
Yes, sir.
Okay, all right, let's quickly look at ANOVA. ANOVA. Now, if you look at the ANOVA, let's view ANOVA. So you see, in this case now, we have the group 3 methods. We have 3 different methods. We have the score, isn't it? So you now watch how the data is grouped. So is this a pivot table or a pivot table? This table, is it pivot or pivot?
It's on pivot.
On pivot.
This on pivot, isn't it? What about this T? Pivot or pivot?
On pivot.
It's
too.
still on pivot. Mhm.
Is this pivot or pivot?
It's on pivot too.
Pivot.
Why this is on pivot?
Because the
Male,
gender is
female, male,
one
female,
column.
male, male, male.
Because
Oh,
what?
It's not grouped now. Oh,
okay, I guess the before and after makes it pivot. Okay, I see.
It's
So is this
pivot.
pivot or pivot?
It's pivot.
This is pivoted table. Why this is what? On pivoted table, you just only see 2 columns. They will group
Yeah.
one and have the value here. But a pivoted table, they will separate this grouping for you.
Yeah.
Can you see that? If I had it like this, before, after, before, after, before, after, whether it's male, female, before, after, before, because these are the 2 values we're interested in. Can you see that? So we have
Yes.
that before, after, and we now have the values. Then it now becomes what? An unpivoted table. Okay. So it's important to understand this so that, because that is how you are going to analyze it. Because that's how R is going to read it. Okay, that's how R is going to read it. So once we have got our data, so we can just call ANOVA. We'll just call it ANOVA. Let's say, okay, I already have the name ANOVA. So let's use which one? ANOVA what? Okay, let's say AOV. AOV. So there's the function called AOV, right? AOV, that's analysis of variance. So what's the formula now? So the score, which is my listing there. So we have the score. Now, if I want to check the names, if I want to check if I have forgotten the names, what do I do? I'll say column names, isn't it? I'll call it what? ANOVA. If I have forgotten the names. So I have group and score. Alternatively, what other name can I use? I can say structure. If I call structure, let me see. ANOVA. Can you see that you give me group score so I can check all the characteristics there? Okay. So if you notice now, this my score is what that dependent variable is it not? So that's why I'm putting the score first. Okay. So I'll put what? The score. And remember, it must be exactly how it's typed here. That's how it's going to be there. Okay. Then we now use the ellipse. So it's like say explained by the group. Okay, so in this case, this is our dependent variable, these are our like independent variable. Okay. Then the data, what's the name of the data? ANOVA. Okay, so once we have run it to see the data, what do we do? If I run AOV, you see that you see the results there, right? You see the results. Okay, but you cannot use that one to make decision, just like summarizing it for you. So to see the result properly, what do? You say summarize AOV. So based on this, what's our conclusion? Based on this, what's our conclusion?
Should be reject still.
Reject HO. So what does that? So what does that tell you?
The probability is less than the 0.5.
Okay, which tells you that what? You know, if you look at the data itself, right? If you look at the data itself, what hypothesis are you looking at here?
Which method is maybe which method is more effective?
Exactly. So is there a significant difference, is it not, among the methods? Is there a significant difference?
Yeah.
Among the methods? Okay, good. So based on this result, what's your conclusion? What's your conclusion?
There's no significant difference among the methods.
There's no significant difference.
Yeah, that's what I think.
Reject.
No significant difference. Do you all agree with that? Do you all agree that there's no significant difference? Eh? Do we all agree there's no significant difference? Okay. So what's your conclusion now? So what is your conclusion? But you know, when you say there's no significant, well, what is the implication when you say there's no significant difference between either of the methods? What does that tell you? When you say no significant difference, but what is the implication of it? No significant difference. What is the implication of it? When you say there's no significant difference.
It means they produce the same level of result.
The same level of the result. So that means whichever method I pick, it really doesn't matter, isn't it?
Yeah.
Because on average, they will take. But when they say there's a significant difference, what does that tell you? When the results say there's a significant difference, what does that tell you?
It means that one method is better than the other. One method.
Thank you. So the method I use matters.
Yeah.
The method I use what matters. Okay. So because you see, the decision you arrive or the conclusion you arrive at will also determine what strategy you are going to adopt. So if based on this your analysis, you say there's no significant difference, that means you can recommend that we can take any of the methods, isn't it? But if you say, oh, there's a significant difference, it means that I now know, okay, if there's a now which method should we go for? Can you see that? So what's our final conclusion? What's our final conclusion?
There's no significant difference between the methods, so any method is fine.
All right. Somebody shouting no. Somebody saying there's significant difference. Somebody saying there's no significant difference. So which one do we go for? Now, if this is still not clear, you can also put it on the box plot, isn't it? Box plot. Now, what's the data? So ANOVA. So let's say score. ANOVA group. So let's see if I run this now. Can you see that now? We have method 1, method 2, method 3. So looking at this now, what does this one tell you? Looking at the chart now, what does this one tell you? Does it confirm your result? Does this confirm your result?
Yes, for method 1 and 2,
Yes.
there's no significant difference, but method 3 is significantly different from methods 1 and 2.
So therefore, your conclusion is that what? Now look at the p-value. Look at the p-value again. Look at this p-value. What is the p-value here? What is the p-value?
P-value
The p-value is what?
is 0 if you approximate it.
0.00, isn't it? So this 0.00, is it greater than 5% or less than 5%?
Less.
Less than 5%.
So if it's less than 5%, do we accept or do we reject?
We reject.
Reject it.
Reject. And rejection implies what? Rejection implies what? So if you are rejecting HO, what does that imply?
No significant difference.
There is significant difference.
Rejecting HO means what? HO is what? No significant difference. Is it not?
Yes.
H1 means what?
There is significant
There is
difference.
a significant
Difference.
difference. So if you are rejecting HO, what are we now saying?
There is significant difference.
There is what? A significant difference. Can we see that now? And that is exactly what this chart is. That's what this chart is showing now. Can you see that now? So we want to now check, okay, if we say there is a difference, where is this difference coming from? Okay, so that's what they call the post hoc test. They call it post hoc tests. Okay, we have several tests, but one of the common tests is the HSD. HSD stands for what? What does HSD stand for? What does HSD stand for?
Honestly,
Yes.
significant difference.
Honestly significant difference. Exactly. So one of the tests is called the Tukey test. That's one of the most popular one. Tukey test. Tukey HSD. Okay. ANOVA. Could not find function. Sorry, Tukey. I think there's no C there. Tukey test. What did you say? Error in method Tukey. Let me see. What is the problem here? Let's see. Tukey. Let me run back again. Say error in use method. Tukey HSD. No applicable methods. Now let me see. So what's the error now? Tukey HSD.
No applicable method.
Yes.
Is the error because it is
Is what? Say the error is what? AOV. So let's run AOV. Can you see that this AOV was the result? Can you see that? That ANOVA was the data.
okay.
So the result that we are run testing. Clear? Is the result that we are testing. Okay, good. So after checking, so we can now see now. So you see that the charts, method 1 and method 2, no difference. Method 3 and method 1, difference. Method 3 and method 2, difference. So it means that the difference is coming from where? Method what? 3. Isn't it? The difference is coming from what? Method what? 3. It's just like saying, for example, you are in the manufacturing, company, isn't it? Let's say you buy your supplies. Maybe, for example, this is a fruit factory. You are into production of pineapple. Okay, pineapples. Now it means that you need to source your raw materials, isn't it? You can get from different suppliers, supplier 1, supplier 2, supplier 3, supplier 4, isn't it? You can get them from different suppliers, isn't it? Now, why you notice that some of the pineapple get bad on time, or whenever you use them, the taste, they are not the same, isn't it? So your question now will be what? What question will you now raise from there?
Why is this happening?
Yes, why is this happening, isn't it?
Because
So
of the different quality of pineapple.
Thank you. What is different? Is there a signal difference in the quality of the pineapples, isn't it? Is there a difference in the quality of the pineapples, isn't it? So it means that, yeah, so is there a difference between the pineapple from different suppliers? Exactly. Okay. So it means we want to test for quality. So how do you test for the quality of the pineapples? How do you test for the quality now?
Maybe you can look at acidity.
Thank you. You can test for acidity. Yes. What again?
Durability.
Yeah.
Durability or
I think I see it.
state.
Shelf life.
Now, whichever parameter you want to use, so for example, if it's acidity now, we'll take acidity. We'll now test acidity across these different world suppliers. We'll now test the acidity across these different world suppliers, isn't it? So we test supplier 1, test supplier 2, test supplier 3 over a period, isn't it? Over a period, isn't it? So while we have checked it now, it can be for over a period of time, it can be a month, a week, so it depends. So you must have your word sample, okay, across these groups. Okay. Now, once we have done that, now the next thing we'll now check that on average, there's no, so we are saying that there's no significant difference in the quality of pineapples among the suppliers. Okay. H1 is saying that there is a difference. Okay. If after running it, we now see, oh, supplier 3. In all this one, we now say the difference is coming from what? Supplier what? 3. So difference is coming from what? Supplier what? 3. So this will be supplier 1, supplier 2, and this is what? Supplier what? 3. So in that case, if this is the one that has, so if it's in terms of acidity now, the higher the acidity, is it better or not?
The higher the acidity, the more is sour. Taste sour.
The more is sour, isn't it?
Yeah.
So the worse the taste, is it not? So in that case, we now can identify where the problem is coming from. Okay. But if in terms of we are talking in terms of the sweetness, is it not? How sweet it is. Okay, how sweet it is. So if we are checking for sweetness now, isn't it? So based on this, we are saying that what supplier 3 is sweeter than what supplier 1 and supplier 2. Then we should go for some. So you see, the way you state it will determine your objective. It is the question that you ask that will determine what the objective and how it is what measured. So it means in this case, the supplier we use matters. But if there was no significant difference, it means whichever supplier I go for, it really doesn't matter because they're almost what the same. I hope we are clear with this now.
Yeah,
is this clear?
Yes. Yes.
All right, great. So this is what we have done so far. So you see, when you are doing statistical analysis, these are the kind of tests that you are doing. For example, have you heard of A/B testing? A/B tests. Have you heard of A/B testing?
I've heard of it. I don't know what it is.
A/B testing.
I can't remember.
A/B testing. You have not heard of A/B testing before? Is anybody in marketing? Is there anybody here that is in marketing? Nobody here that is in marketing.
I don't think so, sir.
Okay. Now, A/B test is just like you are checking, for example, you want to compare two variations. You want to now, please take note. You see this ANOVA. You see your ANOVA. This ANOVA can also be applied for two groups, just like we have in this our t-test here. You see where we have this our t-test here. Can you see this one? We can still apply it for what? Two groups.
We can apply it for what?
Two groups, just like we have this before and after. We can also apply ANOVA for this.
Okay.
Do you get? But ANOVA is more applicable when it's from 3 and above. But if it's 2, it's okay. It will still work. But t-test cannot work from 3 groups. Only 2 groups you can work with. That's just the technical difference between both of them. Okay. Yes.
And they produce the same result?
Yeah, they will arrive at the same conclusion. If you use both, they will arrive at the same conclusion.
Same conclusion.
Yeah,
Okay.
yes. Okay. So that your A/B testing is just like you are splitting into different groups. So you are doing different, maybe random experiments, is it not? So let us give this group, let us put especially people who do this like product design, right? Product design, maybe they put one feature or two features in this for this group, they give to them, is it not? They give another group, maybe without those two features, additional features, is it not? Now let them give their feedback. So at the end of the day, what do you want to do? You want to compare, isn't it? Is there a difference in the groups? So it means that if there's a difference, right? So it means that whether that feature matters or not. Can you see that? So if you want to improve your product, you want to improve your product, is it not? You want to improve your product. So maybe by adding a feature on that product, does it make a difference? If it does not make any difference to the user, is it not, or to the consumer, then there's no point. But if that new feature you add makes a difference, isn't it? Then it means that what? It can what? Encourage people to what? Buy or what? Use that your what product. So again, that's your like your t-test. It's just an application in your what? A/B testing. Okay? In your A/B testing. Especially if you are in marketing, then you can go and check what they call A/B. You go and look for what? A/B testing. Okay? So that's what they do. So it's normally used for what? Experimentation. They will do this type of hypothesis. So that's just a use case for what? This type of tests. All right, now another aspect again we look at. Remember we said that when we look at our data can be qualitative, quantitative, isn't it? It can be what? Quantitative, quantitative, qualitative, quantitative, right? Now let's go to the last. There's another table there. Let me try and report that table. What was that? I think it was that chi-square. Where is it? Let me just bring that last one. Copy. So let me call it chi. Square. The table name. What was that table name? Was chi-square, right? Chi-square. Okay, let's see chi. Let's run that. All right, can you see this now? Can you see this one now? There are two qualitative data. Can you see that? Two qualitative data. Okay. Now you know normally if it was in Excel, if you have this type of data in Excel, how do we analyze it in Excel? If you have this data in Excel, how we analyze it in Excel?
Count.
You do a count, isn't it? You'd have done like what? A count, exactly. You have done like what? A count. And when you account, you just group them. You know, you have your, what they call it now? You have your purchase. So let's say, for example, structure of chi-square. So you have your age. Can you see the age? You have the purchase. Yes, no. Children, isn't it? So it means you group age, you group purchase. Whether they purchase yes or no. Children, is it not? Now, in that case, if you have done that, so you have something like your table. In Excel, you'd have had your pivot table, isn't it? You have your pivot table where you are going to group them, right? Because you would have dragged you will drag what now? You will drag what? Age, where we drag age to? You drag age to where? If it was on Excel, how we have done it? In Excel, how we have done it?
Age will be on the x-axis.
Yes, so you can go to the word rows or the word columns, isn't it? So here, if I say chi-square age, comma, chi-square purchase. So let me run that. Can you see that? Can you see this like a pivot table? Can you see like a pivot table here? So it has summarized it. So you see, these are qualitative. So qualitative data, I can now use what? Chi-square. So it now depends on the hypothesis I want to make. Sometimes I'm saying those age group, is there a relationship between what the age group and their purchasing decisions? Now, you see, in that case, I'm just checking is there a relationship or not, right? Or alternatively, when you talk about the relationship, we're not saying whether it is going to be, we're just saying, is there a relationship, yes or no? Okay? But we cannot tell whether it is positive related or negative related. We're just simply saying, is there a relationship? Okay? So we are showing you here that even when you have two qualitative data like this, qualitative, you can still what? Analyze it. So if I want to do a test, this is what we normally call test of what? Independence. Okay. Does your age group determine whether you are going to purchase or not? So for adults, isn't it? For the adults, what's the total here now? Should be like 100, right?
90, 80.
It was 100, isn't it? Is that 100?
Adult is 80.
Is what?
80.
80, okay, 80. So from this 80, 23 of them said they are going to what? Buy, isn't it? They are going to purchase. Why 57 say they will not purchase? For the children, isn't it? Out of the 80 children, is that 80 children? Is this 80 or
89.
89.
89? 89, right? So from the 89, 57 say they will purchase, while 33 say they will not what? Purchase. Then from the ones that are youth, right? 33 of them say they will purchase, while 67 they say will not purchase, isn't it? So you are trying to find out who will make these people purchase. So which group should we target? Can I see that? Which group should we what now what target? Okay. So in that case, what we want to do is what they call a chi-square test. A chi-square test. So there are different ways of doing it, but I don't know which method would be easier. So if I look at this table as it is, this table, can I write it as chi? Let me use C to put it there. So C. So C represents that table, isn't it? So that C will represent that what table. So what we can now do, we can say the easiest way I would have done is say chi-square. No, let me say chi-square dot test C. Aha. So what's your decision here? What is the decision here? What is the decision? Yes, what's the decision? What's your decision? There's a difference between, okay, yes, there's a difference. And take note again. You know this one, where's that our data just now? You know this one can be put in percentage terms, is it not? So that's why, again, this can also be used what they call test for proportion. Test for proportion. It's also called test for proportion. The other ones we have been doing is test for means. The other ones we have been doing is for test for what? Means. Because remember, for qualitative data, the only thing you can do is to do a count. And again, you can take that count all over the total count. So which you put it in terms of what proportion. So yes, that's why it's called test for what proportions. Okay. So there's no significant difference in the word proportion, isn't it? So no significant. So is there a significant difference or no significant difference? Significant or not significant? Significant or not significant? Yes. Is this significant or not significant? Significant, thank you. So significant. So do you all agree that it's significant? So if we are saying that there's no significant relationship, if HO was there's no significant relationship between the age group and the purchasing decision, H1 is that what? There is a what? Significant relationship between what? Age group and what? Purchasing what? Decision, isn't it? But take note, it will not tell you whether it is positive or negative. It will only tell you that there's what? A significant what? Relationship. Okay.
Okay.
So in that case, if I want to now check direction of relationship,
There are many things.
then we can use what they call correlation analysis.
It's for Reno, mocking, and all naysayers who were triggered.
Got you. Can you please mute?
I was talking about him doing it in the year.
Okay, they know them.
Sorry,
Actually, I
please, shall we-
thought that it's very
Betty,
private.
can you
Can
please?
you mute your mic, please?
Please mute, please mute.
All right, so let's look at correlation now. I hope this chi-square is okay. Is the chi-square test okay?
Yes.
Can you see it's even called Pearson chi-square test? Can you see that? That Pearson, remember in correlation, Pearson correlation. All right, which data do I use for correlation? On that data set, we have regression, right? We have a data set called regression. Okay, let me use that. Let me use that one. So let me import that data first. Let me import that data. So let's go to correlation proper. So let me call it, let's see, data. Let's see, this is what regression. Regression data. Okay, t-tests. Okay, t-test. Okay, let me use that. Let me use that table. Hold on. You know, if you look at your variables, right? If you look at your data normally, you should be able to identify the variables that you have, right? You should be able to identify the variables that you have, okay? In those tables that you have, in the data that you have, right, you have to identify what kind of variable are they? What kind of variable what are they? Okay, remember it can be either be what? Categorical or numerical, isn't it? It can either be categorical or what? Numerical. It can be categorical or what? Numerical. So what we want to do is either we are looking for difference or looking for relationship. Okay. Now, when we look at the data, if, for example, there are two quantitative data, two quantitative what? Data, okay? I can either find difference or I can find what? Relationship. So if I'm looking for difference, I am looking for the difference in the mean or in the average of at least what? Two what? Population or two groups. In that case, the kind of test I will do is what? T-test. I'm checking if there's difference in the mean of at least what? Two what? Groups. Then I can use the mean. Now, where I am looking for a difference and the group is more than two, that means 3 and above. Even from 2 and above, it can be 2, it can be 3, it can be 4, it can be 5. T-test can only be used for what? 2 groups, maximum of 2 groups. Okay, but ANOVA can be used to what? Minimum of what? 2 groups. So it can be 2, it can be 3, it can be 4, it can be 5. So where I have 2 or more groups, I am trying to compare the mean or the average. For example, I am trying to compare the performance of maybe students in LBS and Unilag. That is 2 groups. In that case, I can use t-test. But where I'm trying to compare Lagos LBS, Unilag, and Uniben, I cannot use t-test in that case. The only thing I can use is what? ANOVA. So I'm checking, is there a significant difference in the mean? What you need to understand is that what we are trying to check is the difference in what? Difference in the what? Mean. Or in the average. Is that not it? So in that case, I can use t-test or ANOVA. T-test is only for 2 groups. ANOVA is what? 3 groups and above. Even if I use 2 groups, it will still work. But most I usually use for what? 3 groups and above. I hope that is clear between t-test and ANOVA.
Yes, sir.
Good. Now for chi-square is usually used for what? Categorical what? Variables. Categorical what? Variables. It can be 1 variable, it can be 2 variables. But remember that it's used to test for what? The difference in what? Proportion. So that's the difference. Test of what? Proportion of at least 3 groups. For example, you look at that one. We saw adults. We saw youth, is it not? And we saw child. So we are checking for what? Test of proportion among the 3 what? Groups. So test of proportion, we are using what? Chi-square. Test of mean, we are either using t-test or ANOVA. We use t-test if it's 2 groups. If it's 3 groups, we use ANOVA. Who was asking? Is that clear now? Is this clear now?
Yes, sir.
All right, okay. So all you just need to understand is that when I look at the data, isn't it? It can either be categorical or numerical. And you know, in numerical, I can find the mean, is it not? Or the average. But for categorical, I cannot find the average. The only thing I can do is to do a count. If at all I want to find anything like average, I'll have to do what? A proportion, because it has to be put in percentage. So if I'm now checking for difference in the mean, I can use what? T-test or what? ANOVA. But this one I will need minimum of 2 groups. This one I will use like what? 3 groups. But test of proportion, I can use at least what? 3 groups. That's just the difference. But a technical difference between these two, that this chi-square is usually used for what? Qualitative data. Qualitative data. I hope it's better now.
Yes, sir, Dr. Francis.
All right, that's fine. Okay. So once you have qualitative data, that is why chi-square is the most what? Most widely used what? Non-parametric tests. Okay. Why you see them either use t-test or what? ANOVA. For what? Quantitative what? Data. All right. Did I run this one? Okay, so view data. Let's see data. Aha. So look at this: salary, age, experience, performance. What kind of data is this? What kind of data is this?
Quantitative data.
This is quantitative. This is a quantitative what? Data. Quantitative what? Data. Quantitative data. Quantitative data. Okay, good. So if I run that structure of data, so we can see them. Can you see they are all numeric? So this is how you determine whether they are numeric or the type of data it has. if I have drawn structure of, can you see all these are what? Character, these are what? Qualitative what? Data. Can you see that? So once I have my data like this, I already know that this kind of analysis I'm going to do is what? A chi-square. Because I'm trying to what? Compare their purchasing decision across the age group. Okay, so that's what you use to determine. All right, good. So once we have run that, so to summarize, you can just do summary data. So once I do this, once it's a qualitative, once all your variables are quantitative, this is what they refer to as what? A descriptive statistic. You are summarizing the data without drawing any what? Conclusion. Okay. So in that case, if I want to find relationship, what can we do? I can simply run the correlation. So how do you run correlation? You remember in Excel, how do you run correlation in Excel? How do we run correlation in Excel? How do we run correlation in Excel?
You type in the formula.
You said?
You type in the formula equal to
Equal to what?
Correct.
Correct.
Yes, correlation of this data, isn't it?
Yes.
Now, but you see, this function is usually used for what? When we have just two variables.
Yeah, two variables.
But when we have more than two variables, we cannot use that function, isn't it? So we now have to use what? The data tool, the analysis tool part.
We now have to use what?
The analysis tool part now, analysis tool part.
Okay.
I hope you remember this analysis tool part.
Yeah.
So we just highlight everything here. Labels, isn't it? Maybe I want output range. Bring it, but give me the result here. Can you see that now? Wait, so let's check. I hope everybody here, you are all familiar with how to run correlation and regression in Excel.
Yes, sir.
Yes, sir.
Okay, good. So I'm sure we remember this. So exactly what we have here, we now want to replicate this same thing in R. You know, if it was just two variables, let's say age and salary, I would have just done equals to correlate, isn't it? Array 1, comma, I'll pick array 2. It's not array 2, and I'll run it there. So that is 0.56. So that's what we have here, 0.56. Can you see that? So instead of me running them separately, I will now do it in this. This is what they refer to as what? A correlation matrix. It's just a summary of all the correlation of the variables you have. Clear? So if I was to run regression, how will I run regression now? If I was to run regression, which would have been my dependent, which should be my independent variable here? Which is dependent and which is independent variable here? Yes.
Okay. Let's say age. No, let's say salary.
Okay. Salary is what?
Independent.
Salary is dependent.
Okay, salary is dependent. Dependent on what now?
Oh, okay, I see. Okay.
On the
Dependent
age
on performance.
On age, experience, and performance. Isn't it?
Yes.
So in that case, if that's what we say, then let us run it now. So I'll come to data analysis. I'll come to regression. What's my input? My Y. What is my Y?
Salary.
What is my Y?
The A column.
My Y is what?
Salary, according to the
Salary. So I'll pick salary. What is my X? Everything here, is it not? Is that not it? I will now mark labels. So I'll say output range. I want it in this sheet here. I'll say okay. Can you see my salary now? Can you see the result now?
Yeah.
Can we see the result? So I hope we remember how to
Yes, sir.
interpret it. Is it not? We remember how to interpret it, isn't it? So we look at arrow square. What does arrow square say? Arrow square tells you what? That what? Age, experience, and performance explain about what? 92%
Salary.
of what?
Of the salary.
Can you please take it again, please?
Yeah, I
Salary,
think-
is it not? What is
Yes,
left? What is left? What? 8%. Good.
Yes, sir.
Now, if we check the overall significance of the model, we are seeing that what? Is the model significant or not?
It
Is
is.
the model significant or not? The
It is
model, is
possible.
it significant or not? This model here, is it significant or not? The overall model, is it
It's significant.
significant? How did you know it's significant?
It's less than 0.00.
Okay, 0.0. Now let's check each of the variables one by one. Age, is age significant? Is age significant?
No.
No, it's not.
Not significant. Experience, is experience significant?
Yes.
Yes.
Is performance significant?
Yes.
Can we see that? Which means if I want to predict what salary will be now, let's say I want to predict what the person's salary will be, isn't it? So let us bring the criteria. What are the criteria now? What are the criteria now?
We have
Let's say age.
performance.
How old is the person? Let's say how old is this person? Let's say this person is 50 years. So let us do a prediction. So this is the new data set, is it not? So we have the model has not seen this data. So this person is 50 years. What is the person's experience, years of experience? What is the person's years of experience?
10.
10 years of experience. Okay. What is his performance? Maybe they gave him a task 1 to 50. Or 1 to 50. Is it 1 to 50 or let's say 1 to 50 years? His performance was what? Give a score of his performance.
What's it, 35?
22.
Yeah?
35?
25. Okay, 25. Okay. So based on this criteria, what would be his likely salary? Can you see that? We are trying to predict what his likely salary is going to be. Now let us look at the one that already exists. Let's say, for example, look at this one that already exists. You know, this was the salary. Based on this model, remember regression is about pattern recognition, isn't it? It will go to the past, your past data. Look at your past behavior. Isn't it? Based on that past behavior, you cannot predict how you are going to behave in the future. Okay, so regression is about pattern recognition. So let's look at this. Let's look at this one that already exists so that we can check whether it makes sense or not. So the model will be like this, right? So if I also predict this one now, so this is the actual salary. This is going to be predicted salary. Now this is the actual salary. We already know. Now let us see whether this model will be able to predict this correctly. The one it has already seen. Okay. So to predict it, what do? We use what? That's where your intercept comes in, not intercept plus what? Intercept plus what?
Coefficient.
Yes. Age times what? 50, is it not?
Yeah.
Plus experience. This is the coefficient of experience. Experience times what? 10 years, is it not? Plus performance times what? 25. So what did he give us now?
You picked the wrong. You're supposed to pick the one on 9.8. You're picking 50, 10, and
Okay, sorry. So I'll pick this plus what? This times what? Age. This is not.
Yes, it is.
I think that is the correct one now. Plus what? This times this is not. Plus this times this. Can we see that? The actual was this, the model predicted what? 8.9, is it not? So let's pick another one. Pick another one to test now. Pick another one to test. Let's just pick anyone randomly. Pick anyone randomly. Let's check. Pick anyone randomly here.
24.
Which one?
24.
This one here, right?
Yeah.
Okay, this one here. Okay, good. So if this is what? This one is what? Salary. This is what? Age. This is what? Is that experience? Experience, and this is what?
Experience, performance.
And this is what? Performance. So if I want to do a model like that, so what would I do now? Say equal to this plus this times this, is it not?
Yes.
Plus the coefficient times this plus the performance times this.
That.
So it gave us what? 9.7. What did that one give us?
9.8.
What did it give us?
10.3.
10.3.
So you are going to see that when we do it for all of them, isn't it? When we do it for all of them. So if I do it for all of them now, let me do for all of them so that you can see it. So this will now be what? Predicted, let's say salary, isn't it? So if I want to do it for all of them now, how will I do it for all of them? It will be equals to this plus what? So this one I will lock it now, is it not? Since I want to apply to all of them. It will now be this plus this. I will lock this one, is it not?
Yeah.
Times the first value here, isn't it? Plus this, I will lock it, is it not? Times what? Experience plus this last one, I will lock it times this one. So can you see that now? So let us run that down. So this is salary and this is predicted what? Salary. So let us check. So let us run it now and see. Okay, let's run it. So if I was to plot the chart of it now, let's plot a chart of it. Now, based on this prediction, can we rely on this prediction?
Yes, we can.
Can we rely on this
Yes.
prediction? Does it mirror the past data?
Yes, does.
Does it mirror it?
Yes.
Remember, we can never be exact. We are not God. Though. It's only God that can predict it exactly. But based on as a human being now, based on this past performance, can we rely on this relationship going forward?
Yes, we can.
We can, is it not? So in that case, we can now use this to now do what? The prediction. Okay. So in that case, what do we now do? We can now put the person's salary here, is it not? So what's this person's salary going to be? So I can take this off now, right? Can I take it off?
Yes, sir.
All right, good. So now let's predict this person's salary now based on. So since we have seen the past, we have said, okay, this data makes sense. And again, look at the arrow square. The arrow square is quite high, isn't it? Which tells you the predictory power of the model. So in that case, what do we do? Equals to intercept plus what? This multiplied by what? This plus this multiplied by what? This plus this multiplied by this. All right. So the salary is what? 8 point what? 25. So based on this criteria, this person's salary is likely going to be what? 8.25 million. I hope you understand this now, right? Do we understand this? Hello.
Please,
Sorry,
let's
please,
Yes,
can
we
we
understand.
mute.
So we do.
okay, can we mute our mics, please? There's a lot of noise at the background, so I can't really hear. Okay, thank you. Okay, you understand this, good. Because this is what we are going to try to build in R. Because you know, because R is like code there, so it will look as if it's miracle we are performing. So everybody, are we clear with how it was done in Excel?
Yes, sir.
If it's clear, then we can move
Yes.
over to R. So we can go to R now, isn't it? So let's go and do it in R. So it's exactly the same thing that we have here, but the only thing that we are going to use it what in R. All right, let's go to R. R, okay, good. Now look at the data now, isn't it? Look at the data now, right? So at first we ran correlation. So if I want to run correlation here in Excel, how did we run the correlation? It was a correlate like this, is it not? I think it was correlate, then we chose the, that's all now. So this is the correlation. Is that not the 0.56 we saw there?
Yes.
So it's the same thing now. Okay. Now, sometimes what we want to now do, if we want to do something like this, let me show you. Let's go back to that Excel sheet. This was the data. This was what we ran, isn't it? This is what we ran now, right? So let me do something like this. Can you see something like this? So this one just identify quickly that this is what they normally call a correlation matrix, right? A correlation matrix. But if you plot a chart like this, that chart is usually called your heat map or correlation plot. So you have different ways of presenting it. Okay, so you have something called correlation plot. So if I was to plot a chart of it, just to visualize it, if I want to visualize it, then there's something called correlation plot. Correlation plots. Okay, so there's a library called correlation plots. Now, but please take note, if you run correlation plot and it doesn't work, you have to install it to install packages. What's the name of the package? Correlation plots. Correlation plots. So if in case it does, you run it now, it does not find the function, then you have to what? Install it. Is that clear? But if it has already been installed, then no problem. So we can now run it now. So once you run correlation plots now, let's say that's our correlation plot. Let's call it matrix. Would that be okay? Matrix. At least you understand this one now. When you say matrix now, isn't it? So this is the matrix. So that's the matrix. So if I run matrix, what will come out? If I run matrix, what will come out? What will come out for matrix? If I run the matrix now, what will show?
Correlation.
That your correlation matrix will come out, isn't it? This correlation matrix will come out. Now I want to plot it just like I did in Excel. So you use correlation plots. Correlation plots. What's the name of the data? Matrix. Matrix. So correlation plots. Can you see we have something like this now, isn't it? But this one now, you have this one is just in circles. Okay. So if you go to the documentation, right? If you go to the documentation, you see a lot of this is. So if I type correlation, so if I type, for example, question mark correlation plots. Can you see that correlation plot? Can you see that? This is documentation. So any documentation you want to just put question mark and the name of the library. You see a lot of this thing there. So it's not that anybody will just cram all this in their head. Do you understand? It's just for you can copy it and go and be adjusted as long as you know what to adjust. So you can see by default, you have circle, you have square. Can you see that now? You have ellipse, you have number. So you can keep changing them as you like. Okay. So for example, I'll say correlation plot. What's the data? Can you see the first thing that will come out is what? Data, is it not? Which is the correlation of that state. So which is our matrix, right? That's the correlation, that's our matrix. Okay. Or alternatively, you can run the correlation of what? Data. Correlation of what? Data. Can you see that now? So that is the correlation they are talking about. But since we have done it, we have called it what? Matrix. So let me call it as matrix. Now you have what? The next thing you have is method. Can you see the method? Method by default was circle. So if I want square, so I say method equals to what? Square. So let me run this and check. Can you see that? Can you see how it has changed? Then let me go back again. Let me run it again. Let me run that. Methods. What again? So any of those other formats that you wrote. For example, you have let's see what you have again. Okay, add coefficient AOE. Okay. So you see, you have quite a lot. So if you come down, it will not explain everything. So can you see correlation matrix of the to visualize? Method. How do you want to see it? Type, correlate. Can you see that? Obviously, they will not give you an example of what to do. So you see like in Excel, it has already been pre-programmed for you. But with this one, you can edit as much as you like. So these are examples. You can just copy any example and follow what you like. Okay. If you want a specific color, you can go and get a specific color. Okay. So if, for example, if I say, let's say AOE, let's put, which one should we put for AOE now? Okay. Maybe on the coefficient to show. What again? Maybe methods. Okay, I put method as square, right? I put method as square. So let's add coefficients. Let's add coefficients for the column. Let's make that color, let's say black. Let's run. You say upper, what do you say? Should be in full. Which one should be in full? Say match should be in full. Alternatively, if I cannot remember all of them, what I'll do, I'll just copy one of them. Like if I just copy it, I'll just want to edit it. Can you see that? You just copy it and you just want to edit it. So most I don't always remember all their syntax. I don't always remember all the syntax. So if I don't remember all the syntax now, I'll just put this.
Let me finish ministry. Another ministry. So by
Okay.
9 o'clock.
So let's see order.
I said people should come out.
Virtue.
All right. Can you see that now? So can you see what it looks like now? So you have different ways of also plotting them. You have different ways of plotting them. So that's for correlation matrix. I hope we are clear with correlation now.
Yes, sir.
Are we clear with correlation now?
Yes.
All right, that's fine. But the most important thing is just to run this first one. That's the most important one. Can you see that? It just give you circles and all. But if I just run this one, this will give me the data I said. But remember, at the end of the day, correlation in itself does not give any information, isn't it? The only thing you just need from it is just to know the direction of what the relationship. So that's why we do not take the results from correlation too seriously. All right, so let's look at the data again. So remember how we ran it. So look at the data here, salary, age. What was our dependent variable here?
Salary.
What's our dependent variable? Salary, isn't it? So let's take, for example, let's say let's run a simple regression model first. So when we say simple regression model, what does that mean? Simple regression model, what does it mean? A simple regression model, what does it mean?
That is stating in like an equation.
Is that?
That's
Is it what
that's the model that has one dependent variable and one independent variable.
Exactly. He has one dependent variable and one independent variable. So let's start with that. So let's take, for example, salary and let's say experience. So the model will be salary, is it not? As a function of what? Experience, isn't it? So if I was to write it in full, it will be what? Salary is equals to what? Beta 0 plus what? Beta 1 what? Experience.
X?
Is that how we write it normally?
Yes.
This is how you write the equation now, isn't it?
Yes.
Good. So
Yeah.
if I was to run a simple regression model here, okay, so I can call it model, let's see, or should I call it simple regression model? So the function is called LM. LM is what? Linear model. Can you see formula there? Do you see formula? Can you see the arguments? Can you see formula? So I'll write the formula out. What's the formula? The formula will be what? Formula is equals to what? What is formula? Salary. Is it not salary? Now, as a function of this, I will write it with the ellipse as a function of age. Is that age? Okay, yeah, we wrote experience. Okay, let's write this experience as a function. Please take note, the way it's typed here, that's how you should type it. Otherwise, it will give you error because it's extremely case word sensitive. Then the data, what's the name of the data? The data is what? Data, isn't it? The data is equals to what? Data. Is that not true? It was data we use now, isn't it?
That was data.
It was data, so data. Okay, let's run it now. So we have run it as if nothing happened, isn't it? So if I run SRM now, let's check. Can you see that? SRM. If I want to bring the data in full, I want to see the result in full, like you have your Excel. So I'll say summary of what? The simple regression model. So let's run it. Can you see now? You will now be seeing things like your arrow square. Can you see that? Now, in this case, now, experience, is it significant or not significant? Experience, significant or not significant? Experience, is it significant or not significant?
It's significant.
Is what?
It is significant.
Is significant?
Yes.
Okay, so it's significant. All right, good. So it is what? Significant. Now, assuming now I want to predict, right? Assuming I want to do a prediction now. Let me run structure of, sorry, let me see. So we have, what is the name of data? Data, let me see. So we have salary, we have age, we have experience. So this is the different distance. Okay, that's fine. So let's try and predict, right? Let's try and predict. So if I was to put, if we are saying, okay, this model makes sense for me, okay, and I want to do a prediction. I want to predict, okay. So what we can do, so here we call it X, or let me call it model. Let me call it model. Will you prefer model or you prefer SRM? Which one will you prefer?
SRM is okay.
SRM is okay. Okay. So SRM represents what? The simple regression model, isn't it? So if I want to predict, I'll say predict. So what's the object? SRM. That's the simple regression model, isn't it? Now, remember how in Excel we have to put the value, is it not? Will now be the coefficient, the intercept plus the coefficient times that variable. Do you remember that? So that model already captures what? Your intercepts and your coefficients. Okay, that is what we are seeing here when we run SRM. Look at when I run SRM here. Can you see the intercept and the coefficients? So that is what SRM represents, the intercept and the coefficient. Now I want to put the value. In putting the value now, let's say, because that value I must put in the data frame. What is the data frame? What is a data frame? What is a data frame?
Data frame is arranged in column and row.
Yes, arranged in a column, right? Arranged in a column. So let me see how this one will work. So this one I'm looking for what? Experience. Please check my spelling. Experience. So let's say experience. What value should we put for experience now?
15. 15.
Okay, 15, isn't it? 15. So let's run. So can you see what the DC will be? The salary. Can you see that now? So if this is just for one value, assuming if I have a list of values, for example, maybe I want to predict for maybe like 10 people. Maybe I put 10 people, I put their different years of experience. Or let's say I pick for 5 people. Maybe I pick one 11 years, one 12 years, one 13 years, one 14 years, one 15 years. I want to put all of them at once. So to predict it at once, so what can I do? I'll say predict. The model is what? SRM, isn't it? Yeah. Now I will have to call it in a data frame, right? I have to call it in what? A data frame. So let me say data frame. Now we know how we combine in you know how we combine, isn't it? So I'll say experience is equals to, I will combine them. Let's say 11 years, 12 years, 13 years, 14 years, 15 years. So it means I'm predicting for what? 5 people. 1, 2, 3, 4, 5. I hope this will work. Okay, good. So can you see the first person? So the person who had 11 years experience, this will be his salary. 12 years experience, this is salary. 13 years, 14 years, 15 years. Can you see that's the 15 years you predicted there? So can you see how it works now?
Yes, sir.
Okay, so can you see how it works? So this is how you do what prediction. This is for a simple regression model. But however, in practice, you know it is more of what? You are going to use more of a multiple regression model. Exactly. Use more of multiple regression model. Okay. Now, if we are to run a multiple regression model now, so should I call it MRM, multiple regression model? Would that be okay?
Yes, sir.
All right. Yes. Multiple regression model. Now, let's write the model out. Let's write the model out. So we have salary, is it not? Is equals to what? Beta 0 plus beta 1. Where are the variables now? So let me call matrix. Salary, we have what? Age. We have age plus beta 2. We have what now? Experience plus beta 3. We have what? Performance. But do you notice that what we are doing in Excel is the same thing we are doing in R? So why are we now wasting our time to do all this in R if it can be done in Excel?
R is programmatic.
R is what?
Programmatic.
Yes.
So it gives you flexibility to do to, it gives you flexibility it gives flexibility to tweak whatever you want in the way you want.
Yes, it gives you that flexibility. But another thing again, you take note. If your data set is small like this, please remember with Excel. Though. Excel will help you and do everything you want.
Okay, the large data.
But imagine the volume of data you have is about 2 million records, 3 million records. Can Excel handle that? So that is the sense of why you now need to now come into a program like either Python or what R. And again, R will give you what some more advanced analytics, isn't it? And you can also follow the steps of what to do. Okay, good. So that's the essence of it. So let's try and run it now. So for multiple regression model, now, so let's run that. So we have, so let's run it now. So the same thing, linear model. I have to call the formula, isn't the formula? What's the formula now? What? Salary, ellipse, is it not? So we have what? Age plus what? Experience plus what? Performance. Can you see that? So we have age, experience, performance. Then data, what's the data? So let's run and check. What did they say is missing? Performance. Hey, can you see that? The P must match. This is small p. P must match. It does work now. So if I say MRM, can you see that? That's giving me intercept, age, experience, and what? Performance. So if I want to bring everything out in full, the arrow square and all the rest, I'll do what? Summary of what? MRM. So let's check. Is it the same result with what we had in Excel? What was the arrow square? What was the arrow square in Excel? Was it same 91?
Yes, it's the same.
It's the same, isn't it? It's the same.
Yes.
All right, good. Now let's check the significance. Are all variables significant? Is age significant?
No.
Is age significant?
No.
Is experience
Age
significant?
is significant. Age is significant.
Age is significant. Is age significant? Why do you say significant?
Because the figure, even though it's negative, but it can affect the result, the coefficient.
Based on this result, is age significant? Based on this result, is age significant?
No, it's not.
Why do you say it's not?
Because the p-value is less than, it's greater than 0.05.
That is all you are using. That is all. That is all. In fact, you know why even R is even better? R has even helped to make decision though. Do you know that? Do you notice it put stars there? It put stars for you. Do you notice it put stars for you? The one that put star means what?
Significant.
It means it's significant. The one that there's no star means what? Not significant. So 3 stars means it's significant at 0.00, is it not? 2 stars 0.01. 1 star 0.01. Any other one above this, not significant. Is that clear now? So you see, it is exactly the same thing we have done. So let us do the prediction now. So how do we do the prediction now? How do we do the prediction now?
Intercept.
Predict in brackets MRM.
Is that?
Predict, then open bracket.
Okay. Predict. Mhm.
MRM.
MRM.
Data frame.
You said?
Data frame.
Okay, data frame.
Data frame. Data
Yes,
frame.
data frame, yes.
Open bracket.
Uh-huh.
So we'll take age or experience, so on. Okay, we can take age, yes. Then you see, you combine, see.
Okay, you want us to combine?
I was
Okay,
looking
if
at,
I just want to put one value, if I just want to put single
okay,
values
one
now,
value. Just okay,
for just one value, I don't need to combine. Is it not to age? How much do we put for? How much do we put for age there?
Let's say 25.
Okay, I want to put age 25 years.
Experience.
Experience.
Let's say 5.
Experience equals to 5 years.
Performance.
Performance.
Let's say 10.
10. Okay, his performance is 10. Okay, good.
Then
So based on that, his salary is going to be what? 17 points. Whatever. But another way again we can do it. You know, I showed you that, for example, we can put different tables. But because this one has multiple, it has multiple variables, isn't it? It has multiple variables. In that case, right? In that, and again, for example, if you are predicting, remember when you are doing prediction, you don't predict exactly. You can also predict within a range. Remember, we can also predict within a range. So in that case, we have something called confidence. We have interval. We just call it confidence. Did you run it out? Okay, this one did not bring all of them out. Okay, so I will not bring all of them out because we specified it. Okay, let's do that way. Let's do it another way, right? So that's the value there. Let's do it another way. Let's say, for example, we have let's create a data set. Let's create a data set. Let's create a data set for 10 people. Let's go to Excel. You know, we have run the data. Now we have our variables are what? What are our variables? Is that age, experience, and performance, right? Like this, isn't it?
Yes.
Age, experience. Now let's put any data for me. Take any data there. So the first one we had drawn, which one was the first one we ran? Okay, 25 years, 5 years,
5 and 10.
5 and 10. Okay. So the first one was 25, 5 and 10. Now let's run on that one. Let's do on that 5 or on that 10. Let us predict their salary.
Let's say 30.
Yes?
30.
30.
Yes.
7.
7. And 8.
8. Remember their performance over 40.
Oh, it's over 40.
Yes.
Okay, let's say 30. Let's say 32.
32. Okay.
27 years. Let's say 10 years experience.
10 years experience.
And then 40 performance.
40. Okay.
let's say 42.
42,
Yes, 20 years experience.
20-year experience,
And performance, let's say 38.
38. Okay. So one more. So let's have 5 at least.
We have 50.
Yeah?
50 is the age up to 50. 50.
Okay, 50,
Yes. 30 years experience.
30-year
25
experience.
and performance, let's say 41. Okay, it's up to 40. Let's say maybe 35 or 30.
35. Okay, 35. Let's leave it. So these are the 5 people. Now, this is not a new data set, isn't it? The model has not seen it. Right? So it wants to now what? Predict. So if you are relying, so when we plotted that chart initially, is it not? If we can rely on that pattern, is it not, from the past behavior of that model, we can also rely on this word prediction going what? Forward. So I will save it. So let me save it as what should I call this data file now? Let's call what should I call it now? New data. So let's say new data. New data. So it's an Excel file, isn't it? So I want to import the file. So how do I import the file now? So I want to import the file now. So how do I import that file?
Read.
Yeah? Yeah, so I can just come here to file, is it not? Where's my environment? Import data sets, an Excel file. So browse, new data. New data, yeah, import. So that's my data set, isn't it? So import, all right, great. So this is the data set we have imported now, right? So, okay, good. So let's run it now. So now, before we are entering the data one by one, or would have used what they call it now, would have used the concatenate to mesh together. But now we want to use what? A data set. So we want to now use what? A data what? Set. So normally how we have done it is that we first of all call the model, isn't it? What's the model? So we say predict. Predict what? What's the model?
MRM.
MRM. New data. New data. What's the new data? New underscore data. That's all. Can you see that now? So the first person that we predicted, is it not? That's that. Second, third, fourth, fifth. Can you see it? So if I wanted to do, for example, I want to put interval. So that's when I can now use the interval. So I can say interval. Let's say confidence interval. Confidence interval. Can you see what that's done? So for this one, pay 70, this is the range. So that means that person's salary will lie between that value. Okay. But this is basically how it's done. So if you are using a real data set, so this is how you now what? Pick them and what? Run the regression and do your what? Prediction. Sometimes you may have to tweak the variables. Sometimes you have to tweak them, okay? Because some variables may not make sense. Why some? You have to what? Look for new variables to add if the relationship does not make any what sense. But that's why we say your model, first of all, must ensure that what? Practically, there's a logical relationship between them. Okay? And you can explain what has happened. Then in case I want to write it now, let's say I want to write this result out. If I was to write that result out, maybe I can write to where now? Let's say, for example, I want to write, so predicted. So let me save it as predicted. Predicted. So I'll assign it to predicted, isn't it? So if I want to write it to, I can say write.csv. So I want to write it to a CSV file. What's the name of the file? Predicted, isn't it? What do I want to call the file? Let me say predicted salaries. Predicted _ salary. So I'll go and look for this file. What's the name of the file now? Predicted what? Salary. So let me go and look for the file. Predicted salary. But please take note, so you have to save it where you remember. Predicted salary. If I can find my own. Okay, maybe documents. Let's see. Predicted _ salary. Okay, mine is saving it as a CSV file. So let me say open with open with Notepad. Let me see. Okay, what? Okay, let me just copy it out and go and save it on the desktop. Okay, so let me share my Excel screen now. So let me file, open, browse. It's a CSV file. So let me say all files, predicted salary. Okay. Yes. Well, that's the file though, although it's because it's a text file. So how do you separate it? When you have a problem like this, how do you separate it? How do you separate it? How do you separate it? If you have a problem like this. Can you see my Excel screen?
Yes, we can see it.
Yeah, so how you separate it now?
I don't understand the question.
Separate, is it the age, experience, performance? Because that's
yes,
what
now can you see how this data looks scattered?
yes.
So how we separate it now?
I'm not saying that.
Is that?
I'm still saying the predictor.
It's the new data we are seeing. No?
I'm not saying the predictor.
Okay, let me see. Can you see it?
Yes.
So when you have this problem now, how do you separate it?
Split. Okay.
Yeah?
You can use split column.
You can use what?
Splits. This split column under data.
Data. Which one?
That's text to column. Is it
Text to column, exactly. Text to column. What will I use to separate it?
Comma.
Comma. I'll use what? A comma, isn't it? Comma. Great. So that's the data you have now. Can you see that now?
Please, sir, can you do that again?
Which one?
Yes, just do that
Here,
again.
right?
Yes.
You highlight it now. You go to your data, text to column. They say next. What did they use to separate it? What they use to separate the comma, is it not? So they use a comma to separate each of them. So that's why I'll click on comma here. So this is how you want your data to look like. Yes. Next. Finish. So that's all.
Okay, thank you.
So that is your predicted value. This is the lower and this is the upper limits. Clear?
Yes, sir.
Great. So most of the machine learning algorithm we are going to be doing, we also follow this pattern. Okay, but this, because this is just an introduction, right? There are certain other fundamentals I also need to explain in R before we get into core machine learning in R. Is that okay? Because remember, at the end of the day, sometimes this your model, you have to what, deploy it. Isn't it? So you deploy it either on the website or on the mobile phone app. So that's the essence of why you must what? Ensure when you write your code, it must be ready for what? Production. So this is where what? Data scientist now comes in. Everything we have been doing before is what? The role of what? Data analyst. Going forward from here now, this is what data science school is now. So this is now how you use what? The R. I hope we are clear with this.
Yes, sir.
Clear?
Yes, sir.
How many of us joined for Python when we did machine learning with Python? Machine learning Python. How many of us were here?
I was.
Okay, Moses. Okay.
I was.
Maria. Okay. Moses. Olumide. Okay. Which one is easier, Python or R?
I think arrow.
R is easier.
Python seems easier, sir.
Python. Yeah.
Well, the way you explained it now, R for me is easier.
Are you serious?
Yeah.
Oh, Python is okay.
I prefer Python to R.
You prefer Python to R. Okay. So that's why you see in some organizations, you need to understand what language they use. But either way, even if you have learned Python before, can you see it is easier for you to transit to R?
Yes.
Is it?
Yes, it's easier.
If you
Yes,
have
it
learned
is.
R, if you have learned R, you can easily transit to Python.
Yes.
Because it's just for you to understand what they are doing. Only the language that is different, but you know what you want to do. So this is what they call a bilingual data analyst. That means you understand the different programming language. But why people prefer Python to R is that in terms of deployment and production, it is easier to what? Produce in what? Python than what? R. Okay? But if it's just to run the machine learning, just run it and analyze, then you can just stick with your R. But once it's going into production, that is why most time, even when you have understood R, you must still go and learn how to implement in Python. Okay? You still go and learn how to implement in Python. But whichever one you use, you can be consistent with it. Whichever one you're familiar with, just be consistent with it. But most times you see people gravitating towards what? Python. That's why you see when they are combining tools, they'll combine Python, Power BI. So we combine Tableau R. Okay, Tableau and R. Those are the two sets they work with. Python and Power BI. Those are the two sets we work with. However, you can also integrate all of them together. In all of them, SQL must still be there, so you cannot throw away SQL. So SQL is data you are going to extract, analyze in R, and visualize in whatever, Tableau. Or you extract with SQL, analyze in Python, and visualize in Power BI. Okay, so I think we can end it here. So next week we'll go into some other aspects of some other fundamentals in R, so that we can use that one to build some other machine learning models.
Can we get the codes?
Can we get what?
The codes for today's class in a text file, please.
Okay, the codes. Okay, so let me copy it out. So I'll call it, what should I call it today? Regression or what?
Maybe you can call it today's class 23. Regression, yes.
Maybe 25th. Okay, 25th. 09/2022. All right, so let me I should put it here.
Yes,
Is everybody here on the WhatsApp group?
I'm not on the WhatsApp group.
So I've put it on the chat here. Is it on the chat now?
Not yet.
Okay, say this file is invalid. This file, it says invalid. Invalid file name. Hey, let me look for that name to call it. So let's say linear. Let me show that's going to work. Linear regression. The enemy is at work. Oh. They don't want me to copy it. Okay, let me use a Microsoft Word and see. Let me paste it from Microsoft Word. Let me copy Microsoft Word, paste. So let me save it. So let's say linear regression. Okay, let's try now. Linear regression R. All right, great. So has gone. So what fashion has gone? So you can download it there, and if you want to share it on the group. But however, once you already got these fundamentals, so you can start building on it. You can start building on it. So especially those of you who are looking to switch to proper data analyst role. So just go online, check for some requirements, what they use R to do. Okay. Then check how many of them you have learned and know which one you need to start building. With all this we have done now, we have learned a lot of the basics. Okay. So you can now actually start building on it. Remember, always try and build projects. Work with projects. Okay. Work with what? Projects. By the time you have started working with what? Projects, then you start getting comfortable with it. Please, you don't need to cram all the codes. There's nobody that crams all the codes. Just understand how it works. Do you understand? Just understand how it works. Okay. So you don't
Hello,
necessarily
doctor.
Yes.
Sorry, is there any code in R for selecting all? You know,
Selecting
for select all. You know, for SQL, you select this star.
Okay. For R, what is using as all? I think I showed it when we were dealing with what do you call it now? I think there's this in the use when you are selecting, right? You use a comma. You use a comma or full stop. Can you see that? So that's like saying all. There's one this thing that we use. Let me see it. Okay, let's try it in R. So you want to select all what now?
Like that data. You want to okay, I want to select all, but still filter it the way we always do it. Data and then select, but I want to select all, then filter it at the end instead of selecting each column.
You want to select all.
Yes, but I want to filter it. And
okay.
Like the data, and then select. So most of the time we always put like maybe the age and performance and experience and but now instead of me typing all those things one by one, I just want to say select all and then filter by age, maybe greater than 15.
Okay, so you want to select all columns.
Yes. In R. So I've been looking for it.
Now, if you want to select all columns, let me see. If you want to select all columns, let me see the data. Which data do we use? Data. Okay, let me say view data. So I want to select all this, is it not?
Yes, sir.
So I want to select salary, age, and this. Okay. So most times, let me see which one I can use here. Where was the one? Where were we writing it? Okay. So if I'm using, have I called the tidiness now? Have I called tidiness already?
Yeah.
Okay, if I've called tidyverse, so let's say if I say select and then what?
Filter.
And then filter what? What do you want to filter now?
You know, we have to put the what's it called? Table name or what is it?
I have to put what?
Like okay, we're using data. It will now be data and then select all and then filter by.
Okay.
Yeah.
So you say data, and then what? Filter. So what do you want to filter now?
The data will be before the select.
Okay, I guess. Okay, so this is data, right? And then
Yes.
you want to select. You want to select all.
Yes, we want to select.
Then you want to filter.
Exactly.
So let's say what you want to filter now. What do you want to filter? Let's look at the data. So look at structure of data. Let's see. So what do you want to filter?
Maybe age greater than 50. Greater than 45.
You say where what? Age what?
Oh, salary.
Okay, let's say salary.
Yeah.
Greater than what?
6.
Let's say 8, right? Salary greater than 8. So you want to select all.
Yes.
So let me run this and check. Object salary not found. Object salary not found.
So it has to be data. Exactly.
Let's run this and check. Has it worked? So let's say I call it inside, let's say S. If I say view S, did everything come out?
Yes. Thank you, sir.
Yep.
Thank you, sir.
You have seen it, Abby?
Yes, absolutely. Thank you, sir.
So you just use that open bracket for everything now, instead of putting the names there.
Exactly. Thank you, sir.
All right, that's fine. All right, thank you very much, guys. See you next week.
Thank you, Dr. Francis.
Remember to practice. Yeah.
Thank you, Dr. Francis.
Doctor.
All right, take care.